today we'll be looking into superimposition of the atoms in magnetic field. As we have last time we have discussed that how the atoms, or what we can say how the charge react when it passes through a magnetic field. Now there are a few things that you gotta know before diving into superimposition topic. First of all, a really clear thing that you need to understand is that we do have two axes, right? Okay, let me draw it again. A bit zoom out version. Change colors. Suppose for a while these are two axes. This is x-axis and this is y-axis, right? Now here it is sine theta that works, and here it is cos theta that works. Whenever an atom is moving in this direction, in the cos theta, when there is a value that is added to the cos theta, so the motion of the atoms or of the charge, it can be neutral charge, it can be positive, it can be negative, it depends upon the charge property. But for now, if there's any charge that is in the cos theta side, so it will move in a straight motion. Straight motion. If any of the charge that is moving in this direction, so its motion would be circular, not straight, but it would be a proper circle with 2 pi. Circle. What we have learned till now, that whenever an object is moving in cos theta or along the x-axis, or what you can say along the magnetic field, so its motion will be straight. And if it's in the direction of the sine theta, so its motion would be circular. Suppose for a while that these are the lines of the magnetic field. Let me draw an arrow so you can clearly imagine. This is the North Pole and this is the South Pole. Now here, if an charge is moving in this direction, creating a sine theta, so it won't move straight, it will move in circular direction, or what you could say, it won't replace itself, it will keep moving in a circular direction. But if in a situation E, or it's an electron, it's moving along the axis, so from the north to south, its movement, yes, exactly. So the north to south, the electron will move along the magnetic field. These two concepts, I hope it's clear to you. But it's not compulsory that either electrons or protons or whatever charge we are considering, it will move in this direction or either this direction. It's not compulsory. It depends upon the situation. What if I say that an electron is moving in this direction? What you will say in this situation? Neither it will be considered as the cause, neither sine. So how would you deal with this situation? Well, first of all, you need to understand the motion. Here I have told you three possibilities, that velocity, on depending upon the velocity, there will be first condition, that will be cos theta made it move in a straight direction, and sine theta made it move in the direction that is circular. Now third condition is that when theta is okay, I have made wrong condition. When theta is greater than 0 degree and less than 90 degree. So what you will do in this situation, or how the motion will move in this situation, it would be in this form. It will move, it will be neither circular, neither straight. It would be in form where it is creating an helical or spring-like structure. You could say it can be an spring-like structure. Either you could say it's an helical structure. Either you could say that it is an helix. This would be the motion of an object when, not an object but in charge, when it is moving in a situation that where it is neither at 0 neither at 90. And this is what we call superimposition, where the object or the charge is moving in the in between, somewhere in between sine and cos. And there are different situations and different formulas for this condition. Like at very initial, we all know that whenever a situation is given that 90 and 40 is the situation, and force that is always equal to Q V multiplied by, or what you could say, what if I write VB sine theta? Since it's a dot product, so whenever we'll remove the dot product, so it will give us the sine theta. Okay, let me remove this one. This one. Okay, yeah. So here in this situation, what if I say that F is moving in a situation where it is circular as well? Or we could say that because of the magnetic field that is affecting on the charge that is moving by, just suppose for a while in this situation, it's the force of the magnetic field making it move in a circular direction that we often call the centripetal force. Centripetal force. If you have gone through the previous topics regarding centripetal, centrifugal, and other topics related to the circular motions and all, so it's like centripetal force that is affecting here. So here what I could do is, if I can consider it as centripetal force that is equal to QVB sine theta. Now here FC, what is the formula for the centripetal force? It is mv square upon r, right? And that would be equal to QVB sine theta, right? Now we need to find the value of r, because we need to find the radius, that how much it is moving, what is the distance that it is covering. So for that we need to know the radius. To find the value of the radius, what we will do, here the Q, V, B all are multiplying. After going there it will divide. Or what we can still do is that here the V is showcasing what? V is showcasing the same V as here. So it is a thing where I can say that it is a V that is perpendicular to the magnetic field. And we all know whenever anything is perpendicular to the magnetic field, it's creating 90 degree, that showcases us the sine theta. So I could write here mv square sine theta, or the whole value is squared. I could write here whole value is square. There are two velocities that are working right now. QVB sine theta. Can I cancel out this sine theta and v by this square? So we would left with only mv sine theta upon r, that is equal to qb, right? Here qb is multiplying, after going there it will divide, and this r is dividing, after going there it will multiply. So we will directly get mv sine theta divided by QB, that is equal to R. That's how we derive the formula to find the radius of the superimposition. I hope that you get it, and that's the basic thing. Thank you so much for watching. Stay tuned for future videos.